Welcome to the Bell Tech Talk segment of the Vertical MRO podcast. This segment takes you into the nuts and bolts of helicopter maintenance. It's about safety, support, and operational readiness. Top priorities for the Bell team. Join us for technical insights and personal stories from the front lines of helicopter maintenance from the industry-leading experts at Bell.
Hey, welcome to Bell Tech Talk. I'm today's host, Jon Gray. Have a really cool conversation in store for today. Everyone knows that I love technology and I love what technology affords. And today's conversation is definitely along those lines. We'll be talking about HUMS and all the safety benefits that come with systems associated with HUMS and the technology behind it, some of the history behind it. So really excited to dig into that. But more than the systems, I'm interested in the people that we get to talk to about the systems. So if you guys could just introduce yourself, let us know what your role is, and we'll get into the conversation. And Mark, you're a longtime caller, longtime listener.
I am, yeah.
So if you could just reintroduce yourself for the folks that may not have met you before.
Yeah, absolutely. So I'm Mark Dube. I'm the product support engineering manager at Bell. So I lead the product support engineering team, more specifically, the light and intermediate group. So all the PSEs that customer reach out for any technical inquiries, I'm responsible for them when it's light or intermediate aircrafts, basically. So been with Bell for a couple of years now, and actually been in the industry for more than 23 years. So yeah, I've been around for a while.
Between the two of you guys, there's a lot of combined knowledge in this room. Really cool to sit with you guys and be able to pick your brain a bit. Tim, you're new to the Tech Talk series, but it's an honor to meet you and an honor to have you on the podcast. If you could just introduce yourself and tell us a little bit about yourself.
Sure. Thank you for having me.
Yeah.
I spent a lot of time working for a helicopter operator in the oil and gas industry at 22 years. And in those 22 years, 18 of those I spent as a HUMS manager. So I've utilized a variety of systems, variety of aircraft models. And then now I have the opportunity to work for Bell for the past 5 years as a HUMS engineer for the Integrated Vehicle Health Monitoring team. It's an engineering team that we help design, evaluate, et cetera, all the HUMS systems that Bell works with or employs. And the special thing is that when Mark has a problem that he can't answer, he calls me.
Yeah,
and then I
absolutely.
get to help him support the customer. So still customer facing.
You guys, the power behind Bell in a lot of ways is the customer service. We talked about that quite a bit. All these conversations, in this conversation in particular, surround customer service and giving your customers the information they need to be successful. Love that about Bell, and it always reflects in the surveys, the customer satisfaction surveys.
Yep.
So again, honored to have you on board, Tim, and excited to talk about HUMS because again, it's a technology that I feel like is very beneficial to the industry. As a prior police pilot flying a single engine helicopter over densely populated areas, this is a system that, had we had on board, there just would have been this, for me as a pilot, this extra level of comfort, knowing that there's some additional monitoring going on. For folks that may not be entirely familiar with HUMS, Tim, can you just kind of talk about what HUMS is and we'll kind of go from there?
Sure. HUMS being Health Usage Monitoring System. It's generally was an add-on kit so that you would purchase from a third party or OEM. And it has a variety of sensors, accelerometers, tachometers, that kind of connect to a more or less a central processing unit, a box. It could be a health monitoring unit, a main signal processing unit. There's variety of names. The same capability, the same unique perspective is collect data, vibration data. Also, it will also tie into the flight operational parameters. So you have an idea of what the aircraft is doing during that time of regime and of the flight. So throughout the entire operation, you're going to see data captured in various regimes, and then you can ultimately identify any potential problems that would come up.
It was essentially, like you said, vibration analysis. And, helicopter, the research and development that went into helicopters is absolutely amazing. We joke about, how helicopters have so many moving parts. This system is designed essentially to monitor all those moving parts, or at least components of those moving parts, which is really interesting. The fact that is something that can determine what's a normal vibration and what's abnormal is really cool. Can you talk about some of the initial history behind that? Like, what was it initially developed for outside of the obvious?
So early on in the early 90s and then towards the mid and late 90s, there were several incidents in the North Sea that kind of caused the industry to reevaluate or rethink how the aircraft is being operated and monitored. So based on the vibration sensitive nature of operating components, when you look at a helicopter, it's a bunch of vibrating components. There are ways to put sensors in specific points on a gearbox, or the main gearbox, tail rotor gearbox, etc., and then isolate those frequencies to various gear mesh, shaft orders, any of those things, and then identify what is not normal. And that's the understanding of HUMS, is what is not normal. Because you're going to look at data day in and day out, and you're going to recognize what a trend pattern is, what is good, what is bad. And then when it goes different, that's what you're looking for. What is different? What is an anomaly? And then you start focusing in on that. And there's different processes to do so. But that's the basics. You look at baseline data, and then as you continue to operate, what is different from baseline, and then go further. You interdict maintenance at that point.
And the technology is come a long ways since the early days of its inception. Can you talk about the development, how it's gone from where it was kind of to where it is today?
So absolutely. In those days, we had a lot of strictly vibration monitoring. We were looking at the powertrain, doing multitude of vibration analysis across components, and then got to a point where we wanted to see more information. Technology over the years was able to capture additional information, and that's where we start looking at flight operational data. When we start looking at regime data, during that profile, that flight profile, what was occurring during that? Was it that vibration induced by how the aircraft was operated? And not to pick on pilots, but when we say that the pilot made an inadvertent turn or bank or anything of those sorts, well, there's a reason behind that. And that goes into a different monitoring program. But overall, if that increases the vibration of a shaft, because of that aggressive maneuver, by knowing those type of data points, then you can better evaluate the aircraft.
Yeah, I think people, when they think of HUMS, or at least folks that I've spoken to, they think of HUMS being associated with twin engine aircraft, larger aircraft, and it's changed today. This technology is widely available. Can you guys talk about how that's evolved through the miniaturization of technology and some of the things that surround that?
So yeah, obviously, it started with larger aircrafts, where some of the aircrafts actually requires it for specific operations. So now with the technology, the lightweight of the systems, we actually have most of our platforms, so currently production platforms, have HUMS systems that are available for them. So making it lighter, making it a little bit less costly, so cheaper, has made it available a lot more for customers. But yeah, Tim, you can surely expand on the initial requirements for larger aircraft, like you kind of touched with the incident that happened a couple of years ago. So
yes. So, over the North Sea region, we talk about oil and gas. That's their primary source there. And you have 9 passengers or more, and that's where your twin-engine aircraft mostly reside. So all of the HUMS requirements were stemmed from that area. So you had the CAA that came up with certain documentations that just said, hey, you need to have a HUMS program. You need to have a HUMS system. And then later those documents were revised, and looking right off was CAP 753, which kind of carries forward to today. But additionally, EASA was formed to provide more detailed guidance on that. So EASA more or less said, hey, this is what you really need to do. This is what HUMS really means, and define that pretty well. Ultimately, they defined it so well that the helicopter operators in the U.S. started adopting those documents as guidance because there was nothing available on the FAA side. It became widely known throughout the industry, these are the requirements that we must meet. Now, as we talked about, technology with miniaturization, electronics getting smaller. Then we started adopting that towards single engine aircraft, and being able to stay within those weight constraints and then have a better safety goal for the fleet.
Yeah, and it's interesting. It's not just aircraft that are coming off the factory floor. It's legacy aircraft too, right?
It is, yeah. It is. I mean, a lot of legacy aircraft do have HUM system. I mean, Bell has been in the HUM business for decades now. So we've had multiple different systems with different technology, obviously. So some have older technology that still works perfectly fine as long as you're able to actually go and collect the data and then analyze that data and do something with it. So yes, newer technology is probably faster, takes a lot more data points in the same flight, which it has an advantage on its own. So you'll have a better trending of what's going on with your component. So
I want to go back for a minute to the North Sea. You guys have talked about that a couple of times. Yep. Was it a single incident that took place, or was it a series of incidents that took place that highlighted the need for these systems? And if so, can you guys kind of just talk about what those incidents were and how a system like this, had it been in place, could have averted a potential issue?
So there was a single incident early on, and that drove the particular investigation, drove more deeper understanding of vibrational analysis. And ultimately, as that was progressing through the years, there was another incident. So it just started compounding itself, saying we need to do better. Safety of our passengers is important. So that was a driving force for the industry.
So I'm assuming there was some sort of a mechanical failure of some sort that led to a mishap with loss of life?
There was, and my memory is fuzzy at this point. So
yeah.
There was a gearbox failure or a shaft within the gearbox failed. And it was common to that particular aircraft series as far as there was an initial incident that was unknown. And as the investigation went through, it became noted. And then the next incident occurred, and it happened to be the same event. Each system has its pros and cons, and each aircraft model, has its unique vibration signature. So when we look at the events that occurred over the years, you start to understand where the focus is for monitoring that particular model.
Okay. You talked about this technology, if I understood you right, being required on aircraft carrying 9 or more folks. Is that changing? Do you see any of the regulatory bodies changing that to address more of the single engine aircraft with obviously smaller numbers of folks on board, or do you think it'll stay where it is?
Well, from my opinion, my perspective, I believe that the safety conscious operators today,
Yeah.
they're going to employ a monitoring system regardless if it's regulated or not.
Right.
Specifically in the oil and gas industry, yes, helicopter operators are required by contract to have some form of monitoring program. So we look at that industry as 100% will require a monitoring system on the aircraft for that contract. Now, then we start looking at the other industries, air medical, EMS. That's shifting over time because in the beginning, due to the weight of the system, it was not feasible to put a monitoring system on board and all of the medical equipment needed for that mission. So today we have more air medical aircraft being fitted with a monitoring system because of the miniaturization, the advancing technology, et cetera. So that's shifting as well. And I can say the same for, when we talk about firefighting, now that's becoming more needed and required due to some of the events that occurred last year. And that also, when we look in law enforcement, those agencies are starting to come on board with the safety aspect of a monitored aircraft as well. So it's growing regardless of regulatory nature.
Exactly. And Tim kind of touched on it, but I think customers are starting to be more and more interested in the safety aspect of it. So yes, most platforms like 9 seats and lower is still an optional kit, but it's still a high safety enhancement kit. So it will help with your operations and everything, and even predict your maintenance as much as possible. So
that's a great point. We've talked so far about this system and how it relates to, identifying potential gearbox failure, which, in our industry, unfortunately, a lot of regulatory issues are written in blood because of fatalities. But it goes beyond that. You talk about the maintenance side of things, and using this for predictive maintenance, I think is really interesting, because now we're in a situation where not only does it give you peace of mind as a pilot and as an operator, but it can potentially benefit you on the maintenance side and the predictive side of things. Can you talk about the benefits there?
Absolutely. Maybe before going with the benefits, maybe just talk about the systems that are on the aircraft, John. So one of the things that we hear from time to time is chip detectors. So chip detectors are actually something that's required by certification of the aircraft. So it's a system that has been around, again, since the beginning of the aircrafts, but it's still a system that's required. So when you combine a HUMS system with your chip detectors, that's where it becomes interesting, because you can look at your chip, you can wait for a component to actually have something going on with it, where a chip light would actually illuminate in flight, which is where, okay, well, maybe you would be grounded, maybe not. We know sometimes chip detector will collect, especially when you're assembling components. You might have a hair type chip on a chip light, which is totally normal. You do a serviceability run, and then you're good to go. But in some instance, you can actually have a part, a bearing, or a shaft that has started to make metal, which is these type of events that you really want to catch early on with your system. So you'll see a trend going on. So, but again, it's all based on data, which me and Tim, we understand what data means. And it's important for everybody that operates an aircraft with a HUMS system. What I like to say to customers is, okay, wait, we received data. Let's look at the data. Let's analyze it properly before taking any action on your aircraft. Because sometimes it could be as simple as, okay, well, this bearing has started to trend up. You know what? Grease your bearing, your trend goes back down. Is that as simple as that? It may not necessarily mean that you have a component that's actually starting to wear out. So again, Tim, you can expand maybe on the data and how we look at the data about.
Sure. And when you look at vibration analysis, when you look at monitoring an aircraft, monitoring a system, that we're looking at trend patterns. It's the data over time, and you want to make sure that your data is good. So generally, you see an alert or an advisory. My first question is the data good? What is the data quality from that sensor?
Exactly.
Is it reliable? And if it is, then we move to the next step. What does my historical data look like? Over time, it could be for 10 flight hours, it could be for 25 flight hours or longer. We want to look at over time, what is the data doing? Is it slowly increasing? And if that's the case, there's generally a wear pattern over time.
Mm-hmm.
Now, if there's a step change, it's real low and then all of a sudden it's high, well, that could be a maintenance-induced event. So then you look at what transpired the night before or the previous scheduled inspection. We start looking at these type of trend patterns to determine what type of maintenance to interdict into the program or process. So we look into the data itself. Is it reliable? Yes. What is it doing for us? What type of trend pattern? And then make your decision there. And then if there's some, we talk about data spikes, that could be either a bad sensor or not necessarily bad, it could be loose, and it's not secure. So there's different avenues and ways of treating data. I always like to say, follow the data, and if you go from the source to the result in the middle, how do you get there? And then you ask questions along the way and you satisfy that.
And again, Tim, you touched on it. Okay. Always think what happened just before that spike. So was the aircraft into maintenance? Was there an inspection done? Where was the aircraft? You actually have the flight data also that you can look at when you're doing trend analysis. So, okay, was the aircraft in hover? Was the aircraft in forward flight? What was happening? And then that's where you start getting deeper and kind of creating, I'm going to say, the story of the aircraft, of the event. So, and that's where obviously we work for Bell. We have all the background of the components, all the background. We have engineers here that certify those aircraft. So it's not because you see something that you have to do something, but with our help contacting Bell, we can certainly help you, guide you properly to your decision of what's required for that specific component. So
we've talked about the hardware that's installed in the aircraft.
Yep.
And we've now discussing data. Can you talk about how the information that's collected by that hardware, how that information is then sent into a place that it can be analyzed in the different ways that we can interpret that data?
So overall, an accelerometer is more or less a sensor captures data and it sends it to the HUMS box, to be simple. And in the HUMS box, it does some form of analysis, initial analysis. And then when you want to extract that data, then you offload that data from the box. There's various methods to do that. And then you have software that ingests that information and then puts it into a readable format that you can then understand. So there's an onboard system, and then you have offboard system. And then there's a medium between, there's how do you connect those two together? Is it by a physical media device, USB drive?
Yep.
Is it Wi-Fi? Is it cellular or Ethernet? There's various methods, various system platforms that will utilize either one or more of those methods to get the data off of the aircraft.
And then depending on what you're actually required, because some system, like Tim said, you can have them, all the data will go from the aircraft box and be transferred via either cellular or Wi-Fi to your cloud-based system. So your off aircraft system where you can actually view the data. But on some occasions, some specific operations, you're restricted. You can't really have a cloud-based system. So that's where the thumb drive, the USB stick comes handy, because that's actually where you can ensure that the data is only viewed by your organization or your specific operations as needed.
As Starlink and similar systems become more widely available, can you talk about how that might enable kind of lifetime monitoring in some of these systems?
So I am familiar with the term real-time HUMS, and there are certain aspects about that particular process that's not necessarily accurate in nature. Overall, the data can be streamed via satellite, but it's not what you would think typical data. It is more of a status. And then when an event occurs, or let's say a CAS message comes up in the cockpit for the pilot, the flight crew, then depending on that particular message, the configuration of the system, it may start offloading data via satellite. And then the receiving station, the base, will start getting that and start analyzing data as it comes in. But when we think of real-time HUMS, it's not necessarily streaming vibration data through the satellite system, the network. It is only giving you a status until something occurs.
Okay.
So it's somewhat misleading.
Yeah. Yeah, it's interesting, the bidirectional flow of information as that spreads, how things will change within our industry. And that's something that I'm excited to see happen. Talked about some of the history behind HUMS, the hardware, and then the software side as far as the data analyzation goes. Can you guys talk about a few, I'll call them success stories of operators or stories that you know of where a system like this either helped on the maintenance side or helped identify a problem that could have been catastrophic down the road had it not been identified?
Sure. Back in my days working with a helicopter operator and going through HUMS analysis with some of the folks that worked with me at the time, we were monitoring a particular aircraft model, and it was an input module, input quill from the engine into the main rotor gearbox. And over time, that data was getting growing worse in nature when we think of vibration. And we had also interdicted maintenance for inspections, and those inspections did not turn up anything worthwhile to take action on. So we continued to monitor, and we did a morning flight. And when the aircraft returned, it was downloaded, and the line level maintenance, the mechanic was able to clear the aircraft for flight, because that was his job as far as review the data and give a quick go or no go scenario. And which he did. He did the right thing based on the available information he had at the time. At the same time the aircraft was going through its turnaround process, the data arrived in the HUMS group, which was at the headquarters location. And the HUMS analyst began reviewing the data, and it got more bad, to put it simple, than what it was previously from the night before, from the day before. So that one operation in the morning caused him to contact the operating base and stop that aircraft from flying. As we went through that process, the aircraft was brought back in the hangar, and when that module was removed, there was damage to that input quill that could not be seen through a borescope process. So that was a win scenario.
Yeah. That's the kind of stuff that is super interesting.
I've got two actually, John. That I've got one that was detected where probably the component could have left and stayed into service a little bit longer, which is where I think we'll be able to talk about thresholds after. But the first one I want to talk about is 429. So the 429 tail rotor has flapping bearings. Those flapping bearings are actually elastomers, and sometimes they may be a little bit hard, I guess, to inspect and to determine the serviceability of them. So we had a recent event with a 429 operator that was actually had the HUMS system installed. And whereas the HUMS system has started to detect deterioration in the vibration level of the tail rotor. So sometimes, depending on who you talk on the pilot side, you're a pilot, maybe you can comment on that. But sometimes these type of vibration for the tail rotor can be felt, but sometimes they can not really be felt by the pilot. So there's no real way of detecting it other than going throughout your inspections and inspecting the component, and then every so many hours actually verifying the vibration level of your tail rotor. So, but for this specific customer with the HUMS system, we were actually able to see the increase in vibration level on the tail rotor. And although he was recommended to verify, do a good inspection, it went up to the failure actually of the flapping bearing. So the flapping bearing has two elastomer pucks on each side, and then you have the central portion, and one of those has completely let go. So we were able to see, okay, well, the vibration level was good. It was close to the target values from the maintenance manual. And then all suddenly it started to peak up, and it actually went up to 5, almost 6 IPS on the tail rotor, which is, I mean, in the industry, that's a lot of vibration for that tail rotor. So this is something, and again, I think it's within 6 hours roughly that it really started to peak up. So if you look at the data and the recommendation that would have been with this trend would be really, okay, go look, there's something happening. You might want to pay more attention, maybe just verify the vibration level and change the component before it fails.
Wow.
So this one actually picked it up, and it was a good success. So for 429 operators, flapping bearings, again, are not really easy. It's elastomers. They're hard to inspect, hard to detect when the component is close to where you need to actually replace it. So that was a very good success story. The other example I want to give is the opposite, though. So we had a customer, 407 customer, that had a transmission, and the had a HUMS system installed. And the system, he looked at the system, did not reach out to Bell, but he was seeing one of the bearings, the accessory drive bearing actually, that was starting to trend up. So decided to remove the transmission, look at the bearing. But that bearing, yes, there was very, very minor damage, so extremely hard to see. It's not something you could have seen with your eyes. So on the bearing, but that being said, that bearing probably would have been able to last 1,000 hour, maybe 1,500 hour. We don't know. So it's where Bell kind of comes with our experience on the aircrafts and all the knowledge that we have. It's our platform. We manufacture it. We know how it's made. That's where you got to make sure that you reach out to us and we look at it properly, in order to avoid, you want to save costs, but you don't want to induce costs. So finding that middle ground where, okay, it's now time to replace that component, is where Bell, actually my team and Tim on the IVHM team can help make this decision. So
love that. You talked about the 429. Can you talk about the other available Bell platforms where this technology is available?
Yeah, absolutely. We have, obviously, I talk about the 429. 407 has HUMS systems available. We have the on the medium side, we have the 212 and the 412 that both have HUMS systems available. We are looking into the other platforms, but not yet available.
Yeah. Can you talk about, Tim, the 525 and what that's going to look like as far as the HUMS side?
So the 525 is unique in nature, where the IVHM system, integrated vehicle health management and monitoring, is part of the aircraft. So when we think of integrated vehicle health, so the HUMS system, the HUMS box, is part of the aircraft. It is tied into the Garmin avionics suite. So then now the Garmin avionics suite will communicate with the HUMS box and vice versa. So now it's on the aircraft. It's part of type aircraft. Type cert is what we're going towards. And we also look at how we utilize that data on the aircraft. So any type of vibration health monitoring events can be displayed in the cockpit on the MFD on ground. So just like maintenance messages, if there is a flight crew that says, hey, this transpired, the mechanic can go to the aircraft without downloading and look at these VHM messages to see what took place and be able to begin troubleshooting right away. At the same time, we get the data into our offboard system and start doing analysis that way as well. So it's truly integrated into the aircraft, and that's the big game changer there.
And correct me if I'm wrong, Tim, but I think that 525 is the only aircraft where it's so much integrated, like you said, that you can actually view the data on the screen. So you don't need a website, you don't need anything else than the aircraft to actually start the troubleshooting process. So
that is correct.
And it's also the only aircraft that needs it for type certification purpose. So it's tied to the type design of the aircraft. So
it's not
optional, basically.
Yeah. That's really exciting. That helicopter is amazing. Got a chance to check it out, and really excited for what's to come with that. The technology that comes with that is really, really cool. We've talked again about the hardware and some of the software. For someone who maybe they've got 2 or 3 aircraft they're operating and they're interested in getting into HUMS, but they're not sure what additional training might be required or what is required outside of actually purchasing the system. What does that look like for those folks?
So there's various methods. First, if it's a Bell aircraft, of course, we want Bell aircraft owners to come to Bell for training, and the purpose of our Bell Training Academy. And we do have HUMS curriculums there for a specific model of aircraft that we can provide training. Additionally, outside of that, when you look at a HUMS program or HUMS monitoring for the operators, there is also a great resource of another safety organization called Heli Offshore, and they provide HUMS recommended practices. And it's not just for the oil and gas industry, it's for any operator or individual company that is interested in learning how to manage their HUMS program. So it provides great guidance. I use it today, when we look at other systems and we expect to support the customer. I use that as my guideline to say, okay, this is what the operators are expecting to do. How do we support the customer in this method? So and that's a good resource.
And in addition to that, HUMS, we're talking aircrafts right now, but vibration monitoring systems or any other system are used in many industries. So there are some third-party companies that provide training, on what is vibration, what is a shaft order, what is all those specific terms that are used, and actually where you should install, probably more for manufacturing if you're certifying a kit, but where to install your sensors, what equipment to use. We have Bell equipment. There's many equipment out there, but there are companies that are specifically giving training on vibration analysis, not specific to aviation, but more general in every industry. So,
yeah, again, this is all super interesting to me, what this technology affords, from a maintenance standpoint, from a peace of mind standpoint. Can you talk about HUMS for aircraft under warranty and what that might look like?
Yeah, obviously aircraft under warranty, if you have a HUMS system installed, that's where it's 100%. It's actually mandatory. You will have to talk with Bell Product Support Engineering we will have to determine, okay, well, yeah, your aircraft's under warranty. I don't want to remove a component that's still serviceable. So that's where our role, if you want to have warranty on your component, if you're on the cap, so customer advantage plan where Bell actually supply some of the components, you absolutely need to contact Bell, and then we'll do the analysis and we'll make sure that everything is in line. If we need to remove the component, we'll remove it, but it's a requirement. So it doesn't matter which system is installed on the aircraft. It could be a third-party system, could be a Bell system, Bell approved, Bell certified, whatever. It does not matter. You have to contact Bell before removing any components. So that's kind of where it's a little bit different. If the aircraft is not under warranty, you can basically follow any guidance that you're receiving, and it doesn't really need to be Bell as long as you're okay with doing the maintenance, because you'll be paying for it. So that's where kind of our warranty system kind of ties in. Okay. Have you reached out to Bell? Have you discussed with product support engineering? If we need help, again, IBHM team is on. We'll reach out, but we will help and guide you, making sure that we're not removing components and paying for components that are basically still serviceable. So, kind
of going into the troubleshooting side of things, can you guys talk about troubleshooting and how to kind of talk about best practice a little bit, but some of the things that go along with troubleshooting?
One of the things that came to mind as we were talking about successes is not just the aircraft airworthiness aspect, but also the maintainer, the mechanic, his success, and understanding the system, the monitoring system, the HUMS, and how to use that information. And I remember traveling to an operating base that was several hours away from the headquarters. The mechanic was he was a younger mechanic, nothing wrong there, but the idea is that he had limited experience. So when I arrived, he wanted to ask questions and said, "Hey, I'm seeing this information in HUMS on the main rotor, and it's a vibration I can't figure out." I said, "Well, one, let's take a look at it, and let's identify where that vibration is occurring." And it was noted in flat pitch on ground only, not in cruise. I said, "Well, thinking about the main rotor and from a mechanical aspect, what would be the difference or the cause between both flight regimes? What's different in operating the aircraft?" And I said, focus on that. So go back to your daily inspection and think about what took place. And ultimately, it was a main rotor issue. And the elastomeric that was supporting the blade had physically separated. So it was in two pieces instead of one. Mm-hmm. So in cruise flight, that main rotor load was lifted so that droop stop was not affected. But once you land and the droop of the rotor at idle created that load on that bearing or that elastomeric, which caused additional damage. So by following that troubleshooting process and understanding when that vibration occurred and what regime of flight, he was able to find that particular component, that bad elastomeric, on his own, and his confidence level just increased. Now he was more excited. He wanted to learn more about HUMS and utilize that in his daily activities.
That's a huge part of this system. And I think as we talk about technology, a lot of people are like, well, is this going to, essentially get rid of some of the troubleshooting steps that go into what we're doing? And I think it just kind of enhances that, kind of like what you talked about. You have this extra sense of someone helping you, something helping you that you wouldn't have otherwise. Can you talk about, you've got a point here on chip detectors. Can you kind of talk about chip detectors as it pertains to troubleshooting?
Mark, you want to tackle that?
Yeah,
one?
I can start with that one. I mean, we did touch a little bit on it earlier. Chip detectors, as I said, are the primary system of the aircraft. So if you don't have a HUMS system, you will have a chip detector system. If you have a HUMS system, you will have a chip detector system. They are required for certification of the aircraft. So, and as I said, sometimes a chip can be something that's not actually a component that has started to fail. It could be for assembling the components when you're doing reassembly, piece of metal that got stuck, and then you have it on your chip detector. So they are required. Basically, it doesn't matter if you have a HUMS or not; they're there. So you need them. That's basically what we wanted.
Yeah, to add to that,
Yeah.
HUMS itself is a tool to enhance maintenance. So
Mm-hmm.
because chip detectors are required, regardless of a HUMS system or not, what we look at when we review data, vibration data, is we can confirm a chip as far as
Yeah.
is there vibration leading up to that chip? You know, if there's no vibration leading up to that chip, it could be just an anomaly of, some debris that was real small. Uh, so there's nothing as far as we think of major going on within a gearbox. But to offset that, if our vibration is increasing and our gear mesh frequencies are going nuts when we look at vibration data, then we start to anticipate, will we have a chip light? Is a chip
Mm-hmm.
light coming? Some chip detectors are also fuzz burners. Have we had any
Yes.
fuzz burns, on that particular gearbox? So we're using vibration data, HUMS data, to enhance the maintenance troubleshooting that we're doing.
Yeah, we did talk about data previously, but let's go there again, because that data, as we talked about, can be good or bad depending on how and what you're using to interpret that. So can you talk about data and the, I guess, properly analyzing that data?
So I'll start, Tim, and then you can go ahead and comment also. So data, how much data am I getting? Where is that data coming from? Do I have one single point? Do I have 30 points that I can look at? I mean, is the data real data? Is it a false positive? So we get those from time to time, which mean actually it's triggering something that's not there, which could be caused by the sensor. So looking at the data, making sure you have enough data to take a decision is extremely important. Data goes with thresholds. How's the data collected? How are the thresholds set up? You compare what's normal. You look at what's normal, and based on what's normal, you set up a threshold. Sometimes you may need to adjust the threshold because your normal aircraft that you've been looking at, based on maybe 5 aircraft, compared to another data set where you have, I don't know, 100 aircraft that have the same kit. The data is not going to be the same. So obviously, if it's a newer aircraft, you'll see some stuff with maybe the Tim can expand on that, but the earlier hours, because all the components are new. But at the same time, if you compare data to an old aircraft where all your elastomers have some wear and tear in them, well, again, it's not going to be the same. What you'll look at the system is not going to be the same. So having a good baseline, having multiple points is extremely important. So Tim, you may want to expand on this.
And to add to that, when we look at new aircraft, or even if we replace a gearbox and that gearbox has low time or a brand new gearbox, it could be that when we start operating that aircraft, that component, we want to make sure that we have reliable data. And generally, when we say that is we want a bedding in period. We want approximately 50 flight hours to allow everything to settle in to say, yes, now we're in a good condition, we're broken in, and then we want to be able to set our baseline at that moment. Because if you go too soon, if you put a brand new gearbox on, you're going to get those high vibrations at first because it's still, those gears are still trying to get that bedding in of the mesh itself. So those are some of the things that we want to look at. But also we talk about thresholds. We look at condition indicators. Now there's a
Mhm.
variety of condition indicators that determine the health of that gearbox. So these condition indicators have the threshold set. Now you have primary condition indicators and secondary condition indicators. And what that means is if our primary, let's say SO1, is starting to go higher, then we want to look at secondary indicators to see if we can corroborate those particular indicators to say that yes, there's a there in vibration when you have an action, there's also a reaction somewhere else. So you want to be able to follow that vibration or power path, that powertrain path, to understand that is it propagating further than just the primary sensors or condition indicators. There's different ways to perform analysis, but that is one method.
Essentially, like you talked about, looking for other data that confirms or disputes what you're finding in the data that's being produced by HUMS. Is that accurate?
That is true.
Yeah.
If you have an indication that is going high, but nothing else surrounding it is reacting, then you may have a potential sensor issue.
Mhm.
And then you want to troubleshoot that.
And that kind of leads to, going back to false alarms, if you want to call them that, isolating the source of those false alarms, whether it's a false sensor or something else. Can you kind of talk about that a little bit?
So when we look at false positives or false indications, there's generally a reason why. And for the most part, your thresholds are set too low. And that could be inadvertently or over time that vibration signature of that component, that aircraft has changed due to the variety of components replaced over time. So now you need to reevaluate and understand, are my thresholds in the proper location? Do I need to adjust those? And that's one of the things that we do within Bell is that after we're capturing data, that we periodically review our thresholds to ensure they're continuing to be set in the proper spot or proper location to prevent those false alarms. Because when you have false positives, you are increasing your maintenance cost. So we want to avoid that.
So John, I mean, the example I gave earlier about that transmission, it's exactly what happened. So following the discovery, the CI or the health of that component was slightly above the threshold, but we actually increased the threshold. So the system was a little bit less sensitive to very, very small vibrations. So that's exactly what happened in that instance. So.
Yeah, again, going back to your customer service, you guys being available for your customers is huge. For folks that might find themselves in a position where they need to get in touch with you all to discuss some of these things, how could they get in touch with you, and what's the best course of action there?
The first point of contact within Bell for the technical support side has always been and will always be the customer service engineer. So the field rep, basically, they're located around the world. They're strategically located around the world, so it's easy for them to actually go and visit your facility, be on site with you. When it comes to HUMS, typically what will happen is that your customer service engineer, customer will reach out to your CSE, and then they will both reach out to the product support engineering team. So that's kind of the second level of technical support at Bell. PSEs, we're used to deal with customers. We have PSEs that are specifically doing HUMS system support. So multiple within the medium group or within the light intermediate. So my team, we have individuals that are tasked to look at the HUMS data and then provide HUMS support. And then that's where, after these two first steps, that's where if we need help, we will reach out and start to discuss with the aviation group, so where Tim is part of. So once you reach out to Bell, it's not just one individual that will look at your data. Most of the time, you'll have 3, 4, maybe 5 individuals looking, okay, what are we seeing, analyzing the data, making sure that whatever needs to be done on the aircraft is what actually needs to be done. So,
yeah, a whole team of folks at Bell ready to support y'all. Guys, it's been awesome talking about HUMS. Again, this is a technology that I absolutely love. Any closing thoughts before we walk out of here?
Well, overall, I always believe in HUMS. My entire career has been revolving around HUMS. It's one of my passions. I enjoy seeing the safety aspect come to life when we look at HUMS data and being able to correct any type of anomaly or issue that's arised, knowing that the next passenger that's getting on the aircraft is safe, and getting that customer from point A to point B safely is my goal.
Yeah,
it is. Yeah. And on my side, John, obviously keep in mind a HUMS system is there to help with your maintenance, enhance safety, and don't hesitate. We are available 24/7 to help you and making sure that the data, what you're looking at, you actually understand and take the good decisions for any passengers that will be on board that aircraft.
Well, gentlemen, thank you very much. It's been an honor. I've learned a ton. Looking forward to the feedback from the audience. This will resonate with them, and there'll be a lot of positive feedback from this. So thank you very much for what you guys are doing at Bell. Thank you for what you're doing for our community, and look forward to catching y'all soon. Until next time, we'll see you later.
Thanks, Sean.
Excellent. Thank you.
Thanks for listening to the Bell Tech Talk segment of Vertical MRO Podcast. We want to hear from you. Have a technical topic for the team or a favorite technical tip? Let us know. Our email is techtalk@bellflight.com. That's TECHTALK @bellflight.com. If you're having a technical issue with the aircraft, as always, our team is here 24/7 at product support@bellflight.com. If you like what you heard, subscribe and come back for more.